problem, we are asked to complete the sentence with the word always, sometimes, or never. In a perfect square in standard form, C is a perfect square. So let's just recall real quickly, our standard form is y equals ax squared plus bx plus c. So we're checking to see if C must be a perfect square. So numbers that are perfect squares are 1, 4, 9. So it's 1 squared, 2 squared, 3 squared, 4 squared is 16, 5 squared is 25, 6 squared is 36, and so on. So if we think about the construction of a perfect square, if we put an x by x square in here as an algebra tile and then add some x bars next to it. So let's go ahead and just put some x bars in here. So there's 1, we'll need to add 1 on this side. Let's add another one, build another one here, another one here. Let's just do one more. All right, so this is 1, 2, 3, 4, 5. So it's x plus 5. 1, 2, 3, 4, 5. X plus 5. Okay, so when we're looking at our C value, we're looking at the unit blocks that are added. So we're looking at this space in here. This space that represents C will always be a positive value, and it will always be a perfect square. So in this space right here, this is C, and it will always be positive because I'm taking a 5 times a 5. Now, if it's plus 5 times plus 5, that's a positive. If it's a negative 5 times a negative 5, that's still a positive. So no matter what we do, we are going to get a positive C value in our perfect square for these unit blocks. It will always be a perfect square because we always have to add the same amount of x bars to each side. So if I add plus 5 on this length, I have to add plus 5 on this side. So it's always going to be how many ever x bars we added times how many ever x bars we added, and it has to be the same. So in this case, when we're looking at this, it will always be this dimension times this dimension, which will always make a positive and a perfect square. So in this case, in a perfect square in standard form, C is always a perfect square, and we could even add a positive perfect square.